Hello, fifth grade science. Today is Wednesday, 18. I hope you were able to learn about Dr. Denton Cooley and his first artificial heart and where we've come from since then. So we're going to start our lesson today. The 4 words that I want you to really listen for and learn today are heart, atrium, ventricle, and valve. We're going to go through what all those do. I've attached also another really cool video that shows you how the heart pumps. It's not graphic for those of you that are my squirmish kids again when it comes to blood and all that. I will warn you ahead of time if a video is going to be a little gross so that you can choose to watch it or not. You can watch it with your blinders on so you can easily cover up, but I'll let you know if that ever happens. So spring break just finished, and I'm assuming most of you went out of town and you went by car somewhere, whether it's to the airport or to go on a cruise. I don't know what you did. But I know that I had to travel from my home to someplace. And in order to do that, I got on a side road, and then I went to the turnpike. Now, the turnpike is a main road that goes all the way from the Keys up to Orlando. And it can go all over the state. If I didn't travel on the turnpike, I could have traveled on what? Right, 95. That's another bigger interstate. I'm assuming you all have traveled on an interstate before. What does an interstate highway connect? Right, it connects a lot of cities in the United States. Are all cities and towns near a major highway? No, they're not. You're right. So in those cities and towns, there's smaller roads that will merge into larger main roads and allows you to travel almost anywhere in the United States. Just like this road map right here. You can see Florida down at the bottom. And you can see all the lines. Those represent different roadways, different interstates, whether it's the turnpike or 95 or all these different roads that could go from smaller towns to bigger cities and anywhere in between. Now, our circulatory system is also a transportation system, but it's within our body. And there's different parts in our body that are used in order to transfer blood to other parts of our body. So this transportation system, it transfers blood throughout the entire body. And in this way that God has designed our body so that oxygen and nutrients and in our blood can reach every part of our body. So if I looked at what this would look like in our bodies, this is kind of what our transportation system looks like. All the red lines are blood vessels that take oxygenated blood throughout our body, and all the blue lines would represent all the deoxygenated, or the blood that has used oxygen, back to the lungs in order to get more oxygen. Now, we can think of our red blood cells as kind of a transportation system. If we want to go someplace, what do? We get into a car or on a motorcycle or on a plane or a train, and it takes us from point A to point B, and a lot of times back to the start. Blood and red blood cells in our body that are traveling through our veins and arteries and capillaries, they're kind of like these little cars, these little transportation vehicles for oxygen that we breathe in our lungs. They attach onto those red blood cells, and then our heart is the main organ, a muscle that pumps that stuff to the rest of our body. Without oxygen and nutrients, not only would our cells die, which everything in our body is made up of cells, but you would die too. So the heart is at the center of the circulatory system. Let me show you a picture. This would be where our heart is, in the center of our circulatory system, right there, smack dab in the middle of our chest. It's located between the lungs. Both the lungs and the heart were protected by what part? You're right, your ribs, the bones that protect your heart and your lungs. Your heart is only about the size of your fist. So everyone make a fist and hold it up. And that's the size of your heart. But it's also very strong. It needs to be strong because it never stops pumping. It keeps blood always circulating throughout your body. So I want you to try something. For the rest of this, well, for as long as you can. You don't have to do it right now, but at some point, I want you to just stand on one leg. And I want you to stand on that one leg as long as possible. Eventually, what's going to happen? Yeah, your muscles are going to get tired, your leg might start to shake, and eventually you're going to want to stop. But your heart is a muscle that cannot stop. If it was to stop, what would happen? You're right, we would die. So our heart is something that is a very strong muscle that is designed to always work. And it works and works and works. And think about most people that live into their 90s, late 90s, their heart is beating all the time. It's beat since before they were born to the day that they died. That's a long time for that muscle to keep beating and keep moving. Now, the type of muscle that your heart is, it's only found in your heart. The muscle that's in your biceps is different from the muscle that's in your heart. And it's different from the muscles that's in your intestines that push your poop around. Ugh. But that strong muscle, it has to be that way so that it doesn't get tired. Okay, now our heart is this hollow organ and it has walls. Let me show you a picture of that. Here is a picture of the inside of your heart. It's that hollow organ, which means there are holes inside of it, and it's made of that strong muscle again. And there's this slippery sac of tissue around the heart that protects it from rubbing against the lungs or the ribs. So picture this. If I was to take my hands and just rub them fast, like this, what's happening? Go ahead and try it. That's right, they're starting to heat up. And if I kept doing that over and over and over again, eventually I may rub my hands raw and get blisters or really hurt my hands. Now your heart is so close to your lungs and your ribs that as it's beating, we want to make sure that it's not doing this against your lungs and your heart. So instead, it has that slippery sac so that it protects our heart from any type of friction. Now, inside our heart, there are those 4 empty chambers or sections. These chambers are stacked, 2 on the top and 2 on the bottom. Let me show you a picture of that. We have our right atrium and left atrium, and our right ventricle and left ventricle. Now, atrium, the 2 at the top, it's actually a Latin word that means like if you walk into a really big building and the foyer or the entryway has a really high ceiling, it's called an atria. It's the same thing in our hearts. It's like the very top dome of our heart. So we have 2 atrium and then we have 2 ventricles at the bottom. Now, the left and right side of the heart is divided by this thick wall of muscle that we call a pericardium. So let me show you what that pericardium looks like. This muscle right here is called a pericardium. It's a thick muscle that divides the 2 ventricles. Okay, so the muscle is called a septum that is there. The right side of the heart, it pumps blood to the lungs, and the left side of the heart pumps the blood to the rest of the body. Now, all 4 chambers of the heart work together to constantly pump that blood. The upper chambers will contract like this, they'll squeeze at the same time. So both atrium will squeeze. As they contract, they force blood to flow below them into the ventricles. So they squeeze like a sponge, squeeze that blood to the bottom part. The bottom part's relaxing in order so that it can fill with blood, okay? And while this is happening, the atrium will then relax and then the ventricles will squeeze. When that happens, the blood will flow from atrium to ventricle. Boom, 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 boom. Now, if you put your hand on your heart, you can feel it do that lub-dub sound, lub-dub, lub-dub, lub, dub. That is your atrium, lub, and your ventricles pumping, dub, lub, dub, lub, dub, lub, dub. That's how your heart is pumping the blood. Now the blood flows only in one direction, okay? Blood will enter the heart through the right atrium. When the right atrium, let me get this picture for you. When the right atrium contracts, you see that? The right atrium, when it contracts, it pushes blood to the right ventricle, and then the right ventricle will contract and pump it out to the lungs. Then it re-enters through the left atrium, and the left atrium will pump it down to the left ventricle, and that left ventricle will send it out to the body. Now, the blood that goes through these small flaps of tissues, we call those valves. The valves will open and let blood through, and then the valves close to prevent blood from flowing backwards. We don't want that. We want blood to keep going in one direction. So the heart has valves between the atrium and the ventricle on each side, where the blood vessels, where the blood leave the ventricles. Let me show you these valves. The heart has 4 valves. And it's kind of like this flappy tissue between the atrium and the ventricles. The blood will flow through it. And then there's also a valve right here, and there's a valve right here. One that sends it to the lungs and one that sends it to the body. So we have 4 valves in our heart. And this whole process of this heart pumping and sending blood from the lungs to the body, through the atrium, through the ventricles, it occurs very quickly. Every time your heart beats, boom, boom, that process has occurred. Now I want you to watch the video that I've also attached on RenWeb so you can see a visual of how this heart is beating. Again, it's not graphic, and there are no assignments today. I just want you to watch that extra video. All right, I'll see you tomorrow. Have a great day.